So let's look a bit more closely on what logs are. So log A, B, so log base A, B. That just means A to the power of something, so that's what this something is equal to B. So it's the inverse of exponentials. Okay, now if we don't really care about what the base is, we might just write just log here. Log, so like log 7, for example, without a base. So that, for example, could be used if I'm solving something simple as 2 to the x equals 8. So you should be able to spot just by looking at it that x is 3. Well, I could do that by doing x equals, so doing log 2 on both sides, log base 2 rather, sorry. So on this side, the log 2 and 2 cancel out, so it's getting x. On this side, I get log 2, 8. Type it in your calculator, and that will just give you 3. Whereas I could instead, if I could just do log on both sides, just a general log, so I don't care what the base is. And then what happens now is the power can come to the front, so x log 2 equals log 8. Remember, this could be any base, so x equals log 8 over log 2. And again, that could be any base. It could be base 5, it could be base 7. So I'm just going to quickly show you, for example. So log base 5 of 8 divided by log base 5 of 2. That hopefully still give me 3. And I can use whatever base I want. So 11. Actually, let's do 4 ones. Still get 3. Yeah, so mathematicians normally just either write log like this, which if they did want a number, it means base 10. That's what engineers write. Or the other common one is log base e, which is ln. So ln 8 over ln 2. So again, let's just show you that that works. So ln 8 over ln 2, again, should just give us 3. So if you don't like using bases on your logs, then this is how you can do it. Just either use a general log or use an ln. And hopefully you should now be able to see the difference between something like log base 2x and log 2 times x. Here it's a base, so that means 2 to the power something is x, that's a function. Whereas here this means log base anything times 2, so that's a number, times x, that's a linear function. Okay, so remember the inverse of a log is an exponential. So something like log 3x equals 2. Well, to get rid of the 3, I do 3 to the power both sides. 3 to the power that side equals 3 to the power that side. The 3 and the log 3 cancel out, so let's get x on this side. And 3 squared is 9, so let's get x equals 9. So log base 3, 9 equals 2, and it does work, because 3 squared is 9. Okay, so we can now have a go trying to solve some log equations. So log, let's use a base for the first one, base 2x plus log base 2, 3 equals log base 2, 5. So you might think, and I'll do this in reference mistake, you might think, log 2 can just cancel out, let's get x, add 3 equals 5, therefore x is 2. Well, that doesn't work, because that fact will give me the answer log base 2, 6, if I sub 2 in there. So what I could do, so I'm not allowed to get rid of logs individually, I could do, so I'll do this in green, because it's a quicker way, I could do 2 to the power of this side equals 2 to the power of this side. I can then split this add up into a times, so 2 log 2x times 2 log 2, 3 equals 2 log 2, 5. Now the 2 log 2's cancel out, so I get x times 3 equals 5. So x is 5 over 3. Yeah, the quicker way I was talking about is we've got a rule for when we're adding logs, we can times them together. So log base 2 of x times 3, so 3x equals log base 2, 5. Now when I do 2 to the power both sides, the 2 log 2 cancels out, 2 log 2 cancels out, so I get 3x equals 5, so x is 5 over 3. So I get the same answer, just this way is a bit quicker look. Yeah, so what you do when you practice a lot is you'll think, at this point here, the log 2's kind of just seem to cancel out, which is true, but try to appreciate where it comes from. So we cancel them out by doing 2 to the power of both sides. Yeah, and that would be the same thing if that was log base 3, log base 5, log base whatever. If that was ln, again, the only difference would be ln just means log base e. So now let's compare that to something like this. Log base 2 of x plus log base 2 of 3 equals 5 this time, so I'm not putting the log on that side. And again, I can't just do this. So red is wrong. I can't just do x at 3 is 2 to the power 5. Can't do that. So instead, again, I could do, so green, because this is right, it's just a wondered where, I could do 2 to the power of this side equals 2 to the power of this side. I can split this power up as an add into 2 log 2x times 2 log 2, 3 equals 2, 5. Now the 2 log 2's cancel out, so I get x times 3 is 2 to the 5, so 32. So x is 32 over 3. Or again, the quicker way would just be to combine the logs first. So log 2, 3x, because add means I can times my bit, equals 5. Now, this bit here, you've got two options. You can either change that into a log. So you've got a rule where, let's stick it in this corner, where a number, so let's call it n. So to get n as a log, well, if it's log base a, then I do it as a to the power n. So I could rewrite 5 as log 2 to the 5. Yeah, or another way, this is what mathematicians normally would do, is the inverse of log 2 is 2 to the power. So I can do 2 to the power of this side equals 2 to the power of this side, and that's where the 2 to the 5 comes from. Look, here the 2 log 2 cancels, on this side just get 3 to the x. Here nothing cancels, but this gives me 32 divided by 3, so 32 over 3. Okay, and last one with logs, and for this one I think I'll use an ln. Yeah, sorry, Sash, this rule before I block completely. So if you do ever want to use it, you can always use word ln's look. So ln is just log base e, so that means a is e, so it's like that. So I could write 5 as ln e to the 5, 7, so ln e to the 7, 9, so ln e to the 9, etc. Yeah, if that helps, if you prefer doing that, you can do that. Okay, now last one I just want to look at something like, let's use ln, like I said, x add 3 equals 7. Now again, red is what you can't do. I can't do this. ln x plus ln 3 equals 7. And then take away ln 3 and get rid of the ln. I can't expand an ln. Remember, ln is a function, not a number. So instead, remember, ln means log base e. So I could turn this side into ln e to the 7. and then I can cancel the ln's out. Or mathematically, what I can do is I can do e to the power of both sides. So that on this side, look, e and ln cancel out, so let's get x plus 3. And this side, nothing cancels out, just get e to the power 7. And then to get x, just take away the 3. Yeah, simple as that.